We start with some telemetry displays. We start the TSC, and now we start a test sequence, an automated test sequence that will perform various tests of telemetry extraction. And there off it goes, loading database. It's starting a little simulator. That is not really interesting, it's just a test tool. And you can see the test is running, many test cases, and in fact it's already finished. You can see the test here has passed, and if you look back into the history, you can see all the many different test cases that it ran. And now we'll hide that and we'll look at some of the telemetry displays. We start by looking at TM parameters. There is a tree view of those parameters. I'll just disconnect it so that we can see it a bit bigger. And that's a list of all the parameters in a certain packet, and that's a different packet. And the parameters are organized into different tree structured views. These are the actual packets themselves. That's the log of all the packets that just arrived in that little test. The yellow ones are actually showing a warning, which is actually part of the test. Now I'm looking at the telemetry packet log, and you can see here are the parameters that were in that specific packet. If I click on one, you can see it highlights where the value came from in the packet. I click on another, you see it shows where from the packet it came from, what its raw value is, and what its engineering value is. And these are all zeros, so they're not that interesting, so we'll go and look at one that's not zero. This one is actually the packet time. Look, there, it's not zero. And you can see, of course, the parameters are different size. And now we'll look at a different packet. You see these grey packets here. That's actually indicating that they've got variable instead of fixed parameters. You see there's variable parameters and fixed parameters, and this one has some variable parameters. And again, I can click on a parameter and it will show me where in the packet it came from. I'll click on another instance of a variable parameter, and there's a different number of parameters in it. And again, I can scan through what the telemetry values were in this particular packet. Only this time, the number of parameters is actually described in the packet itself. And what I'm going to prove here is that a different test sequence can get the value of those parameters. That may not seem so special, but actually SCOS 2000 can't do that. I'm just going to prove it. We'll get the second sample of this parameter value. There it is. We say fetch command. And now we're going to try getting a different sample of the same parameter. Look, it's two different samples. Now we're going to look at some other displays, this time the so-called AND, the alphanumeric display. And that's one display from the packet 6000. And there's more or less the same sets as I showed you in the tree views before. We can also add our own new displays. And what you can do is you can drag and drop groups of parameters onto the display. So I'm going to just drag that same familiar packet on there, and look, there's the new display. If I close it, it asks me if I want to save this display definition. So I'll give my own name as the name of the new display, and give it a description. These are fields that occur in the database. Save, and look, there's the new display, the one that I just defined. And there it is. That showed us some of the telemetry displays. And now we're looking at the tabular view. We can see that they're sorted by different fields. By default, the parameter that's in most alarm is shown first. And we can search that display by a string, you see, and filter it. Now we'll call up a specific view, and this one is limited to only the ones that were defined in that view. So it's a shorter list of parameters of the same packet, in fact. Now we're going to look at some other displays, graphs and synoptic pictures. Again, I'm actually going to do this by an automated way. I'm going to run a test sequence. This one is for displaying graphs. And this shows that graphs can both be controlled from test sequences as well as through the user interface. There's our little simulator again. This is the test sequence that's controlling the graph. What it's doing is plotting a couple of parameters and doing a few things to change the time scale, whether the graph auto-scales. If I move the mouse over the graph, then it will show me the nearest plotted value. And the test is doing things like adding and removing the parameter from the display. There's a different parameter. And changing the time scale again. Changing to logarithmic scale. Switching back to the other parameter. And in fact, the test causes the graph to be printed, which I believe it's just done. And we'll quit that test, and it closes the graph. And now we're going to have a look also at displaying some synoptics. These are just test synoptics. We'll look at some more exciting ones later on in the presentation. Again, it's an automated test, so in fact all the pictures are opened from the test sequence. I'm just going to step through that test sequence. You can see it's opening different synoptics and updating them with parameters. If I click on one of those objects, I can actually see the value of the parameter. Now it's enabling some more parameters. It's setting them to a different state. You can see some of them have gone yellow because they're in alarm or they're in warning. You can see I can dynamically resize these synoptics. I can zoom in and zoom out as I like. Let's reset the view back to the default view. Now actually it's printing the synoptic, and I need to give it a file name to save the print to. This is printing to a file, of course. It's closing the synoptic, and that's the end of the short demonstration. Now we're going to look at telecommanding. Again, I'm going to run a test sequence that will actually test the telecommand sending and verification. And off it goes. Now this is quite a long test, and while it's running I'm going to show you some different aspects of the user interface. So this is the status of all the telecommands that we sent so far, and you can see that telecommands actually have different stages that they can be verified at. And that last stage, these are the stages actually supported by SCOS 2000, except there's one additional stage that we've added at the end for finalization. This is actually the list of commands that's defined in our database. And now I'm going to have a look at the list of telecommand packets that we actually sent. And you can see them as they go out and as they progress, as the test progresses. And here's yet again a telecommand packet log, where we can see all those packets. And we can click on the different packets to see what the values of the parameters were in those packets. Let's click on one. And you see this one had 2 parameters, and you can see its raw and engineering value. So it was an engineering value was given when this packet was sent, and that was translated into a raw value. You see there the raw engineering value is 2.3 and the raw value is 7. Here the engineering value was 2, the string 2, and the raw value is 2. And looking at exactly how that telecommand is defined, you see here you have the possibility to send a string, and we have a choice of the different string values it could have. And here we chose the string 6, and it is decalibrated to a particular raw value. After defining these arguments, we can drag and drop them either to a manual command window or to a test sequence. I'm not going to send that command because that would actually disrupt the running test. I'll just show how you can drag and drop command definitions into, for example, a new test sequence. This is making a new test sequence. We call it show TC, and we just wait for the editor to start and create this new file. Here's the new file. Yes, please create a new file. And now we're going to drag and drop that command into the test sequence. And look, that's the TOPI string statements needed to send that command. Anyway, how's our test getting on? You can see that it's progressing. Let's have a look at the status. You can see this test is actually verifying the different results that a command can have, which can be pass, fail, that one's failed. That one was, this one failed, that was unverified, superseded, passed, and affected, which are different statuses that a telecommand result can have, and these correspond to the SCORS 2000 ones. They're a little bit complex to explain right now in the demo, but these have different results that a command can have. Now we're going to look at command monitoring. We're actually skipping through towards the end of the test. You can see we've exercised different results that the command can have, including all the different stages. These are the progress stages that we're testing at the moment, and I'm hoping we're going to see the result. Here we go. This is showing us testing the different progress stages of a command as they pass through the onboard system, and this one actually was designed to fail in the last stage. Now that we're talking about commands that have been loaded into the onboard timeline to execute later, and for this we have a special view that shows us the commands that were loaded by mistake. I've created 2, so I'll just hide one of them. And this is showing us that a command is waiting on board to begin execution. And actually what we're modeling here is that we will wait a certain time. We're actually going to wait a minute. So I'm going to skip that minute and come back. And if we're patient, you can see this is the command being verified as it was executed on board. So it was the verification here has been delayed until it's executed on board. It comes from the onboard mission timeline. And actually you can see that our verification test finished. And we can have a look again at the actual command packets that were sent. And select a couple of those packets. And here we can show the parameters and the raw values. We can just expand that view. And there you can see again more or less the same parameters. And in this case they had slightly different values in fact. Now we look at some complex commands which are defined to have nested repeated groups. Now you see here this is red because it's missing some parameters that you must fill in. You can't send it unless you specify those parameters. So I'm just filling in some of those parameters. And some of those parameters are actually repeater values, so that tells you how many repetitions will follow. You see here I've asked for 3 repetitions of a nested group of commands. I'm just filling those in, and unless I fill those in, then I can't send this command. And I have to fill in all the repeated values. This command is actually intended, it was a real telecommand, it's actually intended for reconfiguring the onboard mass memory of Spacecraft. I think it was Herschel Blank. And so actually one command can reconfigure the onboard mass memory into different stores for different packet IDs, and that's what we're configuring with this command. Okay, so we're nearly there. Setting the repeaters, and again we just set some dummy values. And now that we've finished populating it, you can see it's not red anymore. That's because it's done. And we can then drag and drop that to the manual command, and there it is. It's defined all the nested. Now we're going to look at some CLTU generation and debugging of test sequences. And we have here a test CLTU handler, and actually this test runs incredibly quickly, and maybe that's the problem, that I have to slow it down, and I'll do that in the debugger. You can see here the test results are logged. It's actually running through a set of EGSE defined test cases. And they're quite a complex test case, including things like authentication and BCH coding. Now you can see there's a filtered log. I'm going to turn on debug logging so you can see a little bit more about what it's actually doing. And now I'm going to debug that test sequence when we run it again to make it go a little bit slower. This time I'm debugging instead of running it straight through. When we start the debugger, I need to unblock the Windows firewall. It's a good demonstration. And for this test sequence I want to enable debug logging so that we get detailed information from this test sequence. I'm going to step through it one step at a time. Now it started the simulator again. And step again. Again. It's just stepping wait time this time. Now I'm just going to run through again. And it's finished again. The test sequence is finished. The debugger is just logging that it's finished. This time you can see that we get a lot of detailed information. We see each CLTU code word, and then the full contents of the CLTU, including the header and the trailer and the authentication information. This is how to get online help. You can hit F1 or the help menu, and the help is the same as the user manuals. It's just converted to an online help format. And you can skip through the index, just like this. It gives you instructions. You can also search the index. I'm going to search for the word frame. You can see there's different references to the word frame in there, telling us how to handle frames. And there's a specific frame processing command here. We get some instructions from it. So that's how you can get online help. Now we're going to try selecting a different project. This is quite an interesting one. It's the Tropomi project, which is quite an advanced instrument EGSE, which was done with both Siemens and Space. And look here, you can see there's different test packs for different projects and available. And the one I'm going to choose here is Tropomi. There's Tropomi. So I'm going to tell it to install Tropomi. It goes through copying various files into place from the Tropomi test pack. Now it's doing some special Tropomi configuration. Some projects need a special configuration because they have their own values that they want to save, and this one has a little user interface. We don't have a lot of the equipment here, so I'm just going to configure without a front end, and I'm going to configure without a lot of the simulator and real-time simulator and front end, just for the demo. But now you can see here all the configurable settings which have been set up. Those are all the many standard settings. They're in a kind of tree organization. And look, you can see there's a set of specific configurations needed for the Tropomi project. And now that I've installed and configured Tropomi, I can run a Tropomi demonstration. It's quite like I said, this is a complex instrument EGSE. It's just loaded the database and it's automatically started a special Tropomi controller test sequence. This would be for controlling the real-time simulator, which actually isn't here. This is for doing some science data processing with MATLAB. If I turn that test sequence on, then actually it's waiting for the science. This would be for configuring the instrument, which it does through Microsoft Excel. Running a very quick test, but actually because there's no front end there, the test doesn't do anything. And just tells us some version information about Tropomi. Okay, well we don't have much here, but let's have a look at some things we could simulate. First thing we're going to look at is what's the Tropomi database. And one thing that's you can see, we have a viewer of all the databases that are loaded. And I say databases because Tropomi actually has a merge of several databases. I believe there are 5 in Tropomi. And it's automatically loaded and merged all of them. You can see here I'm searching for a power database. It's for the power SCOI. See, I'm filtering there for data that relates only to the power SCOI. There's another database there for an instrument called the SWIR. Most of the data in here is for a thing called the ICU, which is the Instrument Control Unit. That's the SWIR database. It's got some interesting features in it, which we'll look at in a moment. But anyway, we can use this as a nice browser to see what data we have loaded. I'm going to show a special feature now, and what we're going to do, you see this button, it says drop the database. If I hit that button, the database is unloaded, it disappears. Whoops, you see, it's gone. No more database. All the test sequences are automatically suspended. What I'm going to do is resume them. Even though there's no database, they can still run, as long as they don't try to use anything in the database while we're sitting here with no database. Now, you see, I've just loaded the database again. And you saw how fast that was. That's a big database, and it loaded extremely fast. This is a fast system. And we're looking again at the database. Now what I'm going to do is show you again some of the displays. And at the moment, everything in there is 0 because we have no values. There's no telemetry coming. I'm going to show you some synoptics. Again, the synoptics here are a little bit more exciting than the ones we saw in the test case. Here's a synoptic of the Tropomi instrument. You see we can rescale that up and get a nice little picture of the instrument. And there's some buttons there for the ICU status, and it's got quite a few synoptics for the ICU. Here's one for the onboard software. These synoptics were actually automatically generated. You can see all the values here are 0. That's for the power front end that's part of the Siemens EGSE. Still it's all 0 because I'm not actually getting anything here. This is a nice little synoptic. We're looking here at a wheel, a slotted wheel, whose rotation is controlled by stepper motors and whose position is detected by counting the slots with phototransistors. So the telemetry actually tells us where the wheel is. I know that telemetry is housekeeping, so I'm going to search for the ICU housekeeping. And there it is, nominal housekeeping. So what I want to do is simulate that packet as though it had arrived from the ICU. That number I've highlighted is the number I need to know because it's the packet ID I'm going to simulate. So now I'm going to type some magic simulation code that will generate that packet as it's defined in the database. So I give that special number that's defined in the database, and those two flags 1, 1 mean simulate the header and the body of the packet. Oh look, there is a packet, a telemetry packet, and that's actually generated within the system itself according to the database definition. And look, there's all the parameters, although you'll see that all the parameters currently have the value 0. So when I click, you can see everything is just 0 because that's the default. We never actually received anything. So now what can I do? What I'm going to do is give one of those parameters a value. And to be nice and interesting, we'll change the rotation of that wheel. And the parameter name is that funny value, JCT51013, I think. Set parameter, and we give the parameter name, and we're going to force it to have the value 2. And if you watch the wheel, you'll see it actually rotates. Oh, there it goes. And you can see in the synoptic, I'll just update that, it's value 2. And you can also see it's also computed the angle from the raw value received in the telemetry. It's used that angle to turn the animation of the wheel. Now what I'm going to do is generate the packet again, and this time I've generated a new packet. But this time you will see something interesting, which is that this time the packet actually contains a new value for that parameter. Where is it? JCT305013, I think. There it is, value 2, and look, you can see in the raw packet it has the value 2 now. So let's move it again and give it a different value, value 3. Oh, and there we go. And this time we'll simulate the packet again, and you can see yet again we have a new value simulated in the packet. And this can be an extremely useful feature, not just for testing, but for other kinds of EGSE use, like for example generating SCOE telemetry. You can use it to send out telemetry or to simulate the onboard system, so you could pretend to be the spacecraft onboard computer just by having its database. And now, actually, if we look at those ICU synoptics, you'll see they do actually have values. They're still 0, but they have been received from a telemetry packet. And if we go back to the alphanumeric displays, you'll see if we look at, let's just find a good there it is, nominal housekeeping. And you see we have the nominal housekeeping values. And now we're going to try looking at some rather complex commands that are defined for Tripomi. There's an interesting case for the sphere where it has to upload a variable number of registers, and the registers have an address, and there can be and there's an interesting way that we can do that is actually something that only this system can do. And it's called using deduced parameters in TSC, and this is useful if you just want to reconfigure a limited number, not all the registers, but only a few of them. You can see here we can have between 1 and 80 registers, register settings, and I've chosen to do 4. So that means now it's automatically filled in the length of the packet, and you see now I have 4 registers that I can set. And what I can do here is I can actually choose from the list of those defined registers. And this is what's called deduced parameters, because I give, when I enter that register name, which corresponds to the same register name as it would have in telemetry, it then translates that register name into the address inside the sphere instrument. And I'm just picking at random some of the different registers in the sphere. And it's translating those into their address. Now you can see we have this thing called dynamic from TM. That means if we don't say anything different, then it will take the current telemetry value when it sends the command. So I'm going to give 2 explicit values and leave 2 as dynamic from TM, and then try to send this command. Now, actually this has failed because we never received any telemetry from the instrument. So I'm going to, in this case, I must send the TCs with a real, the TC where the registers are given a real value, because we never received one from the instrument in this case. So I'll just fill those in. And now we're able to send it again. And this time he's accepted it. And we're going to have a quick look at what was actually sent in the TC. And here you can see the actual values we sent. See, those are the addresses, and those are the values we sent on board. So it builds up this TC from this variable list of parameters. And that concludes our short demonstration. Thanks for listening.